Welcome to all. This is part 6, I think. Yes, part 6. For the batch, it is 38EF, I think. I will write in the title. You don't worry about it. General public, it is part 6. Before I start this one, see, my commitment, actually, I have not made a commitment with anybody like that. What I told earlier is, I will go for flexural analysis of single A end post, W end post and T section in detail. Flexural analysis means finding ultimate MR of the cross section. Its application is not considered there. So already single A end post over. I should go to W end post now. But it is not that way. Only from beginning, so many concepts I told, so that it is useful for everybody. I want everybody to learn. That is, using this class, they should improve the knowledge. And one more thing called teacher's instinct. I decided, when I give all this information, why not give little more information so that maximum people are benefited. So, now what I decided is, single end post section, ultimate MR calculation is over. I will go for some more examples, but there also ultimate MR will come. But that you have to do. When you require to find ultimate MR for any question further, for a single end post, what I will write? Cross section, B, D, AST, FCK, FY, XU max by D. Then I will tell XU max, compare, under end post, over end post, therefore MR, over, ultimate MR. That you should work out referring to the two questions solved earlier. I will consider little application now. How that ultimate MR is used. So, but before that, some extra concept required. See, today I am covering partial safety factor gamma F for loads. Before starting, remember, as per IS code, for dead load plus live load, it is 1.5. This partial safety factor for load is factor of safety against overloading in limit state method. Now, in working test method also factor of safety is there. Here it is called, see, one word called partial. Symbol is gamma. In limit state method, there are two factor of safeties. One is partial factor of safety for material, other is for loads. F means maybe force. Actually loads, F stands for force. In working test method, it is combined together. It is just single value, factor of safety, but little higher. There, for concrete, factor of safety is 3. See, M30 concrete. Crushing stress is 30, but permissible is only 10. Even though concrete will get crushed at 30, they are permitting only 10 Newton per mm square. Now, here, that 3 involves not only material variation, but also overloading. But in limit state method, it is separately given. See, this gamma M for steel, it is 1.15. For concrete, it is 1.5. This 1.5 is not this 1.5. Higher safety margin for concrete, lesser for steel, because concrete is unpredictable. You cannot tell exactly good concreting is done or quality is good. You require safety. But steel, well defined, factory made, 1.15. But this will not include factor of safety against overloading. So therefore, now you are coming to partial safety factor gamma F for loads or factor of safety against overloading in limit state method. Okay, I love that one. Now, before going further, I will come later. Okay. Start. First, consider here. Come this side. Two types of, some statement I am dictating, you should write. In limit state method, when you consider loading solve, two types of loads are there. Two names are used. One is service load or working load or actual load. That is, you can write what is the service means what actual. what is the real load applied or actual load, service load. What I will do is sometime for a point load, I will take symbol of W. UDL, I will put W per unit length, intensity. Another is called factored load. Sometimes people call ultimate load or failure load or collapse load, different names. At what load it will fail or it will become unfit for use. So I will add one suffix here, U, that is IS code symbol, U, etc. Same this point load, I will write WU, here see WU. Now, I will come this side now. Come this side. See, during design, there is no problem. People understand very easily. Service load is known. When you design so that structure will fail at a higher load. So, one more thing now. See, different names are there. Now I will do one thing. I will stick to only one word. I will use service load, make a note, means actual load, and factored load is ultimate load. That's all. I won't write everything now. During design, there is no problem. Factored load equal to service load into gamma F. Little later you can make out, wait for some time. But in case of analysis, I have seen general confusion, especially for students and even for others also sometimes. What is doubt? Sometimes you have to multiply, sometimes you have to divide. Actually, sometimes you have to multiply, sometimes you have to divide. But remember, whether you multiply or divide, but first note here, sometimes I told you have to multiply, sometimes divide, depending on the situation. And remember this concept, what? Sometime multiply, sometime divide, it will be more clear, will be more and more clear when I consider application for beam problems. Some problems I will do in the class, beam problems. That is starting from part, today is 6 actually, when I start part 7, that is next part. But do one thing, right? Sometimes multiply, sometimes divide means not as you like. It depends on situation. See, whatever is that one, remember, factored load equal to service load into gamma F, service load equal to factored load by gamma F. That is, whatever load you are actually applying, structure should collapse or fail at a higher load, multiply. Or suppose you know, this is, if you know right here, this is to be used when service load is known. Right? Make a note here, you should write something. Factored load equal to service load into gamma F you have to use when you know the value of service load. Or suppose you know at what load beam will collapse, factored load. How much load you are applying a load or how much load you can apply. Then if the failure load if is known, for safety you apply lesser load, divide by gamma F. But remember, general confusion I will fully clarify in such a way that non-technical person or somebody walking in the street, he should know English and little mathematics, at least high school level mathematics. He can understand. Then you can surely understand. Okay. And more of this one will come in the coming up classes. Okay. Now, factored load, I told service load into gamma F, etc. I will make everything clear now. I will give some example for you. Example. First real technical, then some practical example so that you understand correctly. Make note of everything. You are not losing. Okay. I will rub everything now. This much you should know before I go to next part. Now, first Simple example, technical. See, imagine load of 60 kilonewton. 60 kilonewton. Remember, it can be a point load or distributed load or any load for that matter, even any type of load. If it is distributed load, total is 60. Here it is 60 kilonewton. Here, total 60. Okay. That is not required. Or just imagine a point load only. Okay, what is there? A load of 60 kilonewton. This is the actual load. Actual load. Or this becomes your service load. Service load. This load you want to apply on a member. It can be a beam or anything. Now, I will ask a question in the class. If this is the real load applied, do you want your structural member to fail at this load? Students will tell, no sir, safety required. Therefore, if you are really applying 60 load, then the structure should fail or collapse, fail at 60 into gamma F. I will take 1.5, okay, 1.5. Say 90 kilonewton. Now you are safe. Why? You are actually applying only 60 kilonewton. That's all. But your structural member will fail or will become unfit. Actually, fail means what? It will reach limit state of collapse. That all concepts here I can't cover. One concept, star class, is still pending. That is, your response has not come. So, now you are safe because you know actually applied load is 60 kilonewton. But you know it will fail at 90. So you are safe. Okay, one thing. Or suppose another structure, another member, it is found that at a load of 150 kilonewton, it will fail. Not this way, curvature will be there. Okay, plastic collapse. It will fail. I will ask the question in the students. Existing structure, can I apply 150 km? They will tell, no sir. Then how much I can apply? 150 into 1.5. This much is we can apply. We can apply. The moment I write this one, all students will tell, sir, no sir. Why? Sir, 150 you told it will fail. How you can apply 225 kilonewton? Then, sir, for safety, sir, it is not into, sir. It is 150 divided by 1.5 equal to 100 kilonewton only. See, if you know that actual load is 60, let the member fail or collapse at 90. If you know that the member is failing at 150, for safety, apply only 100. So here we multiply, there we divide. Simple confusion. One small thing I will tell. Suppose I have taken so many batches. People write in the class, they solve the problem, make note, notes will be there. Sometimes a student who is not regular, very, very reckless or highly irregular, he will have confusion. See, sometimes in one question only, one place I will multiply, one place I will divide. See, in the questions coming in the next class, in one problem, for UDL, for point load, I will multiply, for UDL, I will divide. In the next question, I will set the question that way. For the UDL, you divide, but for point load, you multiply. Students will look at the notes. He get confused. See, sometimes multiplied, sometimes divided. When to multiply, when to divide. Last time point load multiplied, UDL divided. But this question, point load divided, UDL multiplied. But suppose his friend is asking, what's your problem? He will tell, I am getting confused. So suppose someone is asking, oh, your sir, teacher, has not made clear. He will surely tell, no, it is my fault. I was not regular. I was not serious. It is my fault. 100% he made crystal clear for everybody in the class. So he will admit it is his fault. So far, nobody put the blame on me for confusion. They know that it is their mistake. But if the same notes, somebody else will see, not my student. See, sometimes people give their notes to friends. Then he may get confused. He will ask, he is not my student. What is this? Sometimes he multiply, sometimes he divide. Last time, you point load he multiplied, UDL he divided. This question, point load he what? Point load he multiplied, UDL he divided. And one more question, both he multiplied. What is going on? He may tell that lecture is not good. Let him tell. Why? It is not my problem. Who come to my class, I clarify. Now, when you are attending this class now, it is understood you are my students only. You can accept it. Surely, I can give better knowledge for you. So, if you accept, good for you. Okay. Therefore, this all confusion, I will clarify as I take the question little later now. But now, I will go for practical. See, this is a technical example. Practical example. Which even common man on somebody in the road, but who knows English and a little mathematics, he will understand. When to multiply, when to divide. Very simple. See, one first example. Just to make a note, imagine a person is constructing a building in a commercial area. It is a corner site. See, it is a corner site. So, corner site means what? He is constructing here. He can give entry here and also entry here. Or he can give both entry. He is constructing. He started going to the site. He was cleaning the site. Some industrialist or he approached him. He asked him, are you constructing a house? Yes. What purpose? Residential. How many floors? Only ground floor. That's all, sufficient for me. But that person told, industrialist, no, I have got a factory there. I require a go down for storing the materials. I am looking for a good place. See, my place is quite nearby and your site is a big site. Ideal if you can give rent for me, first floor. When you construct, you have one more floor. Ground floor, you only stay. He will tell. First floor, give rent for me. Then you ask him, no, cost is more. He will tell, funds I will give. No problem. Funds all I will give. But later you give me. In the rent you can deduct it. He told, construction cost, he will tell, I will take care. And I will give at least 10-year contract. So, rent will be lesser or I will pay more rent also. Finally, you are happy. Why? You are not spending more. Little rent also will come. After the agreement is over, building becomes free for you. Okay, now, you already approached the designer and told him, I want to design a building. So therefore, the roof, ground floor roof, is for ordinary purpose. There is no storage. Now you have to go to the designer once again because your roof will become his floor where he is storing. Therefore, before you go to the designer, you ask the industrialist, okay, renting is okay, tell me how much load you are going to apply. He should know. Suppose you are storing highly weighing materials or some machinery is all, slab may be weaker, you require thick slab, you should account for it. So finally he will tell you, see, he will tell entire area slab I am going to use for 60 tons. See, actually kilonewton required, but ton is better to understand, 60 tons. So he told, you construct your roof or my slab so that its capacity is 60 tons. Agreement made. Okay, now you go to your designer and tell him, see, now I want a new design where the ground floor slab or his floor should be able to sustain a load of 60 tons. He told 60 ton is the total he will use it for. But you will tell him something else. What? The designer also will tell you, see, 60 ton correct. Shall I make it only for 60 tons? No, 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 no. Make it stronger. So what? Imagine you need factor of safety of, for example, not 1.5 to understand. Imagine 2. 2 is better to understand. Why? Multiplying by 2. You imagine factor of safety required is 2. Okay, done. So you tell your designer, actually he told agreement we are making so that he should not store more than 60 tons. But for my safety, I am staying in the ground floor. Night time, one more entry is there. He may bring a truck and put more my entries here. I will be sleeping. He may store more materials. Even though agreement is for 60 tons, who knows, he may put 10 ton more or 10, 12 tons more without my knowledge. If something happens, then I am in trouble. Therefore, I want utmost safety. So do one thing. If you design the slab so that this slab will fail at 120 tons. How? 60 multiplied by 2. See what you have done? 60 ton is the service load. 120 ton is the collapse load, factored load. Okay, over. Now, example 2. Once again, same building, but not same case. But this time, it is existing building. Existing building. You got a building of ground floor, first floor. This is your ground floor. This is first floor. This is the slab where he is storing. See, last time design you multiplied. Now analysis. This is vacant. You want to give for rent. Somebody asks you, oh, I want that place to be rented. Why? For storing something. Then you ask him, okay, how much you are storing? He will tell something. You cannot give directly rent for him. Therefore, he told something, some weight. Okay, then you go to your structural engineer and ask him, see, this floor I am going to rent it out for some industrialist who is going to store something there. Please tell me, when the agreement is made, how much I should permit him. See, how much I should permit him. For that, he will see, your structural engineer will see what is the depth of slab, what is the AST provided, lengthwise and widthwise, etc. All the steel he will check, concrete, which grade used. See, drawing is an existing building, constructed last year. So, structural drawings are there. He will use all this calculation and finally he will tell you, see, your slab will collapse if he stores material weight equal to, say, for example, 36 tons. Okay, leave it, leave it 60 now. 36 tons. So, structural engineer told you, your roof or his floor will collapse when he stores load of 36 tons. Now time has come, not 36, sorry, 1.5, something, 80 tons, okay, 80 tons. Anyway, round number, no, 2, 80 tons. Now you think mentally, you are staying in the ground floor. When I give for rent, he is going to store. If he stores 80 tons, the slab will collapse. I want to be safe. Therefore, you want safety margin of 2. Therefore, you make agreement for storing maximum of how much means, in the class I will tell 80 multiplied by 2 equal to 160 tons. In the class I will tell. Again student will start shouting, sir, no sir. Why? Sir, this time 80 is collapse load, sir. So divide. Ah, good. So wrong. 80 divided by 2 equal to 40 tons. Last time 60 tons he want to store working load. You design the slab to collapse at 120 tons. This time 80 ton it will collapse. So you are making agreement to store only 40 tons. Suppose by chance without your knowledge he puts 5-10 tons extra, nothing will happen. See, margin is there. Very simple example. Okay. Now, furthermore, one more. It's a rubbing one. Usually I lose that one sometimes. Here. Now, to make the things clear, I'll rub later, then I'll write. One more example, money matter. Now, no doubt, see, money matter. Just one example, one. Common person will understand. Imagine you are going for a tour. Tour you are going. And imagine you have no debit card, no credit card, no electronic transfer facility, no bank. You don't have a bank. Someone will tell, sir, everybody will have it. No, imagine, not now, maybe earlier days, when this electronic facility was not there. Debit card, credit card, nobody is knowing. Otherwise, I can't give example. What money you take, you can spend. If you require more money, you are stuck. You finally decide that total expense, say maybe 1 month tour, total expense may be approximately, you decide it is 2 lakhs. You are going with your family or 2 lakhs, imagine 2 lakhs, including everything, 2 lakhs required. Now, you see, if you have shortage of money, you cannot pay by debit card, credit card, electronic transfer facility is not there, no, nothing is there, only cash transaction. Now, suppose you want factor of safety of 2. I will ask the students, how much money you should take to be safer side? Sir, 4 lakhs, sir. Why? Sir, expense coming is estimated to be 2 lakhs. There can be unknown expenditure, danger, sometime problem can come. If your factor of safety is 2, better take 4 lakhs. Oh, clear. So this is what? Multiply 2 with 2. Not 2 lakhs, sorry. Both are 2 actually. Tell 3 lakhs. Okay, 3 lakhs. You should take what? 6 lakhs. Why? 3 lakhs is the actual expenses multiply by factor of safety of 2, take 6 lakhs. Somebody on the road also will understand. Or, second example, money matter. Second example, imagine you are employed somewhere. Your monthly salary, you don't have any other income. Salary is 80,000 rupees. Sufficient, ordinary person. But that person is very cautious person. He plans for future house, secured future, medical emergency may come, and he want to buy a vehicle, he want to be safe, he want to save for future. So he is not a lavish spender. He is a very what you can call is careful spender. Okay, now he wants a factor of safety of 2. 80,000 rupees is his salary. Now, I will ask the question to students, how much per month he can spend? How much per month he can spend? He can spend. I will tell first, 80,000 multiplied by 2. Before I write 2, they will start shouting. Sir, no sir. You multiply. Sir, that is something else, sir. That is safety, you take more money. Here, for future, you save the money, sir. So therefore, wrong, sir. It is 80,000 divided by 2. Oh, crystal clear. See, when it is clear for them, I will tell them, do you think I am not knowing? Yes, sir, we know you are playing with us. So be careful. Sometime divide, sometime multiply means you should think situation. This is second money matter. Furthermore, I cannot tell now. Sufficient, I think. Now, before I close the class, one real concept for your ultimate MR, I will write in the board and then explain to you. Why? It will take some time for writing. Now, make a note first. General for strength of materials, where this factored, ultimate, those words are not used. Strength of materials. When a structural member is loaded, the cross-section of member, say beam, today we will talk about beam, is subjected to some bending moment. And cross-section has capacity to resist bending moment. That is called MR. Now remember, bending moment is external. Resisting capacity is internal. So many people I told, they are giving wrong information. Even high-level people, I don't want to tell where, they are telling bending moment is internal. Let them come in front of me. I'll prove they are completely wrong. Now you can make out. See, they only will, those people who tell bending moment is internal, so hard, such a spirited voice. When it comes here, they will tell, see, they will tell you this way. If you apply bending, if you apply, how you can apply internal? They will only will tell, if you apply a bending moment, then you should not apply more than resisting capacity. They will forget that they told bending moment is internal. Okay, leave it. This actually becomes a joke for my students now. Okay. Now, see, you are applying, once again I'll tell you, you are applying some bending moment. See, bending moment. It has got resisting capacity. Now for safety, bending moment for cross section, you should not apply more than MR of the cross section. At the most, you can put equal. See, I will apply bending moment now. Safe. Now I will apply more bending moment. Gone. See, gone. Why? I applied a bending moment more than resisting capacity. Okay. Now, therefore, for safety, bending moment for cross section should not exceed MR of cross section. Example 1, bending moment 100, resisting capacity 120. See, you are applying 100. See now, resisting capacity 120, safe. Case 2, you are applying bending, see what happened to the scale, bending moment of 140, resisting capacity only 120, not safe. Then, no, now note, in limit state method, we cannot allow bending moment to service load to ultimate MR of the cross section, because I'll tell you, ultimate MR of the cross section is bending moment when cross section fails. Okay, actually not fails, when beam fails. Okay, simple language. Some may tell not beam. Okay, I will tell, I know those things. Don't tell all these things. I am teaching ordinary people. It will fail, ultimate. Suppose, to understand, you apply a load of 100 kilonewton. Can you allow the bending moment to reach ultimate value? Sir, no sir. Oh yes. So, if you apply 100 kilonewton, let the beam fail at 150 kilonewton. Correct? Therefore, we cannot allow bending moment due to service load to reach ultimate MR. But we can allow bending moment due to factored load to reach ultimate MR. Why? Because you are applying only 100. Beam will fail at 150. Okay, done. Now, in limit state method, for safety of a beam, language changes now. See, here I told bending moment should not exceed MR. Here, you have to add extra. Factored bending moment should not exceed ultimate MR. Both are same. Factored bending moment should not exceed, see, this is the applied bending moment, factored. That is ultimate strength. Use this to check safety. Make a note. Whenever they give a problem where you are asked to check the safety, you should write all these things. Then find the factored maximum bending moment, find ultimate MR. By this time, you should be champions to find ultimate MR. And then compare. Use this, and then compare. Then you have to compare, right here, compare. Where I wrote here? Somewhere I wrote, I think. Use this for check the safety. Okay. Use one thing, write something else here. Statement, you write. In such cases, find the factored maximum bending moment. Also find the ultimate MR of the cross section, right here. Compare, no paste right. If that bending moment is within the MR or even equal to MR, safe. If that factored BM exceeds MR, right, not safe. Now, but when we have to find unknown value, in the exam question they will ask you, what maximum load is permitted? In such cases, not compare, then not compare. Compare. Equate factored maximum BM to ultimate MR of the cross section. Check the safety means compare. Find unknown load means equate. I will give an example here also to make perfect now, so that no one has got doubt about this one. Sometime what compare, sometime equate, somewhere I like it. Okay. I won't bother about other things now. Okay, no problem, leave it. I won't use water all. I don't know where is the, there is one rubbing paper is there, it's here. Okay, now see, it will become crystal clear now. See, modern day, imagine junk food, pizza. For that matter, so far, I never eaten pizza because I don't go for junk food, but I don't know how much is cost of pizza. So if I give some value, you should not comment, hey, this person does not know what the pizza costs. Okay, imagine one pizza costs 100 rupees. Okay, I don't know, maybe small size, 100 rupees. Somebody is paying, you are eating. So he will order 6 pizzas. 6 pizzas. See, that person who is paying has some money in pocket. Some money in pocket. Okay, no credit card, cash payment. So here, total cost or bill will come 600 rupees. I don't have to calculate. Now, check the safety. How to check the safety? Compare the money in the pocket to total cost. Now, see, suppose that person has got 350 rupees, he is unsafe. Why? His capacity is 350, bill came 600. So you can tell the bill, bending moment, 600 bill is more than 350, not safe. Suppose he has got 750 rupees, you can tell 600 is the bill is still 600. It is less than what? 750 rupees, safe. So whenever you have to check the safety, don't equate, compare. We want which one? Bending moment to be lesser, resisting capacity more. Now, second one, finding unknown. Okay, see, now, one pizza, second example, costs 100 rupees. Somebody is having 800 rupees. He wants to calculate what is the maximum number of pizzas he can buy. Let it be X number. Then what to do? Cost equal to 100 rupees into X. Money is 800. What do you do now? Now not compare. Now equate. So 800 rupees equal to 100 into X. Your X will come 8. See, last time food bending moment applied. Check safety or not. Now not that way. You should think before applying. Now you not compare now. Now you equate. How the total bill equate to money. Student will tell, if you have 800 rupees, one pizza costs 100 rupees, how much you can buy? Sir, 8, sir. How? Sir, so simple, sir. Yes. So simple there. Here confusion. Okay, now I'll stop now. I'll start next part 7 where, and part 8 also, I'll give you 3-4 beautiful examples of application of ultimate MR where one simply support beam or cantilever, some loading combination, UDL point load, sometimes I told you have to multiply, sometimes you have to divide, all I will explain. Study thoroughly what all told today and get ready for that. Thank you for watching.